In this exercise, we are going to discuss about how to classify ward-wise population of Mysuru City into three groups as low, moderate and high using 2011 census data. To perform this task, we need ward boundary map of Mysuru City and ward-wise population. First, we will discuss about boundary map. Ward map can be collected from city authorities. If it is in digital form, we can use it directly in our software. Or if it is available on hard copy on the paper, it can be scanned to convert into soft copy. We are seeing the collected map from Concerned Department of Mysuru City, which shows the ward boundary with ward numbers on top of it. When we collect a map, it may not have latitude and longitude information on it. To work with GIS, location information is necessary. Without location information, the data is unusable. Hence, it is necessary to collect the locational information to perform georeferencing in GIS. Look at the map here. We can see red dots on the map with index number. These dots were not presented on the map when it was obtained. These are ground control points chosen by GIS analysts to collect the latitude and longitude information on the ground. It is important to note that selection of GCP location should be available on our map as well as on the ground. The GCP location should be a permanent feature on the ground, for example, road junction or building corners. GCP location should not change over the time, like boundary of water body or temporary shelters. In our case, the locations are selected at the intersection of two ward boundaries or corner of ward boundaries. It is important to understand that the boundary what we see on the map will not be present on the ground. Hence, it is necessary to go with a person who is well known these boundaries on ground. In this case, the locations were identified with the help of revenue bill collectors who are much familiar with the boundary of wards. Once the location were identified on the ground, latitude and longitude information can be collected using GNSS receivers. GNSS stands for Global Navigation Satellite System. Nowadays, GNSS is available in most of the smartphones. Now we will discuss about how to use smartphone GNSS app to collect the information of latitude and longitude for image registration. Go to Google playlist in your mobile and search GPS waypoints. You can see GPS waypoints app. It is a free application. Install it in your mobile by clicking on install. Once the process of installation is over, click on open to open the app. It may ask you to access few information in your device. Click on allow. Once the application is open, look at the top of the app. We can see three tabs in the name of dashboard, satellite, sky plots. Now we are looking at dashboard window. Here, latitude and longitude indicates the location of your mobile phone. Altitude indicates the height of mobile from mean sea level. Bearing and speed indicates the direction and speed you are moving. The accuracy indicates how accurate your latitude and longitude information are. Last update indicate when the information of your location was updated. If you walk with your mobile phone, you can see the information on the dashboard is changing continuously. Click on the satellite tab. Here we see number of global navigation satellite systems that provides a signal to our device. Look at the bottom. Now this mobile device is getting locational information from 4 GPS satellites which is launched and maintained by United States of America, 3 GLONASS satellites which is launched and maintained by Russia, 6 other GNSS satellites, and there is no signal from any SBAS. SBAS stands for Satellite Based Augmentation System. Click on the Sky Plat menu. We can see the locational information of satellites. Click on NMEA. Here we can see the downloading location information from the satellites. To get the latitude and longitude of specific point, go to the place and stand there for few minutes till we get higher accuracy and write it down or save in your mobile as screenshot. The location information can be saved in digital form. To do that, click on Add Waypoint option on the left down of window. A new pop-up window will appear on the screen. Mention the GCP name. In this case, I enter GCP1 as name and click on Back on Mobile option followed by a click on Save. Now the window shows the location of saved file under Waypoints tab. Come back to dashboard, move on to other place where we want to collect GCP. See the latitude, longitude and accuracy. If everything is okay, click on Add Waypoints and specify the name. In my case, I specify as GCP2. We can also create a track or path of our travel using Start Path option. Click on Start Path on the middle down of window. A pop-up window will appear on the screen. In it, the app is asking, do we want to add points manually to create the path or let the app itself create the point for specific interval of time. I choose add a point every X seconds and mentioning 5 seconds followed by a click on OK. Now we can see in the middle of the window a new tab is added in the name of path and provides the information of recording path. To finish the path recording, click on Finish Path. On the pop-up window, click on checkbox of enclose the lines to form a polygon if you want the path should be saved as polygon, or else leave unchecked. Enter the name on DIST01 which stands for distance 01. In my case, I am saving with default name. Now we can see the saved path under Paths tab. To see the waypoints and paths, click on the 3 horizontal line at the left top of app and open respective tab. The saved GCP and paths can be exported by clicking on Export All option. I am exporting it in KML format, which is the native file format of Google Earth. To open the saved files, open File Manager and open the folder called GPS-Waypoints. If you use Google Earth app in your mobile, you can open it in Google Earth by double clicking on it. Go to other options and settings in the app and learn more about it. Now we will move to Mysuru Ward map. Here we can see the latitude and longitude information of each GCPs in decimal degree format. Using this latitude and longitude information, we can register Mysuru wards. We will open this map in QGIS and perform georeferencing. I have saved ward map on the desktop and I am opening it in georeferencer window. As we have already discussed how to perform georeferencing in QGIS, I will go through a little faster to complete georeferencing quickly. It is advised to register all the corner ground control points first, followed by inner ground control points. Hence, after registering GCP1, I am moving to GCP Once you have entered all the GCP's values, use transformation setting tool to assign geographic coordinate system and save location. Look at the error of georeferencing and process it. Open the georeference image on canvas and save as this with projected coordinate system. As Mysuru falls in 43 north in UTM projected coordinate system, use UTM zone 43 north to project it. Open the projected image on canvas. To add the population information for each ward, it is necessary to create a polygon for each ward. We have already discussed about creation of vector data in QGIS. Now, I create a polygon vector data, assigning correct coordinate system and saving in the name of wards in the folder of Mysuru City on the desktop. Adding attribute column name as ward underscore number. Type is whole number and let the length default. Now we can see a ward layer added in layer panel. Click on toggle editing and start digitize any polygon on the ward map. Once the first polygon is created, enter the ward number on the pop-up window followed by a click on OK. To avoid overlap and gaps between the boundary of adjacent polygon, we should use snapping option. To switch on snap, go to project on menu bar and click on snapping options. Click on magnetic icon and activate other option on the toolbar. Change into advanced configuration in the second tab. Now we can see the vector layer list that is opened in layer panel. In our case, it is wards. The type should be vertex and segment. Let the tolerance be 50 and the units are pixels. Click on checkbox under avoid overlap, then close the toolbar. Now digitize the adjacent polygon by starting inside of existing polygon. These existing polygons are connected and my new polygon is touching the boundary of these polygons, the common boundary will be taken automatically. By tracking the layer in the layer panel, we can change the order of layers on the canvas. For example, I am moving the wards vector layer down of pro image. As less area vector layer is arranged down of the large area raster layer, vector layer is hidden. By moving the vector layer on top, we can see it. At the end of digitizing all the ward polygons, you will have completed ward polygons as shown here with the attribute information of all the wards in attribute table. Digitize all the wards polygons of Mysuru City as your weekend exercise. The ward boundary map with GCP location on it and latitude longitude information table will be provided to you through link. Recap of today's lecture. In this video, we have discussed about how to collect a map for our task, how to select a GCP location on a map for the purpose of image registration, how to use smartphone GNSS application to collect the latitude and longitude of a place, how to create adjacent polygon using snapping option to avoid gaps and overlap between polygon boundaries. To know more about QGIS, visit www.qgis.org. In next video, we will discuss about how to collect the population data for wards of Mysuru City and how to classify these into 3 groups.